Now this article is from the Daily Telegraph, which is quite a well respected newspaper in the UK. Earth heading for mini ice age within 15 years. It's a picture of policemen ice skating on the River Thames in 1900, and the article goes on. But you'll find lots of these on the web, and a growing number of scientists are actually stating that there will be a mini ice age. So what's it all about? What are the various theories, and why is everything adding up to 2024? Let's go and have a look. Okay, let's have a look at some orbital dynamics. Now this is a very simplified diagram, obviously, and it shows the normal situation. Normally the Earth is in a very nearly circular orbit around the Sun. The Earth, by the way, is the green blob. Now you've also got two really huge gas giants in the system, and their gravity has an effect on our orbit, but normally they're diametrically opposed. These are the two red dots, and they orbit very slowly. So yes, their positions change relative to each other, but only over long periods of time. So what's going to happen now? Well, if we take a look at my next layer in this drawing, we will be able to see exactly what's going. And this is what happens. When these two gas giants, Jupiter and Saturn, actually gather on the same side of the solar system, our orbit bulges outwards. But cosmically speaking, by a small amount, it's not quite as dramatic as is shown here. However, although you're only looking at a 6.7% change in the distance of the Earth to the Sun, it does actually make a huge difference. And this is what is going to be the case in 2024, and these gas giants are moving into this alignment. They started moving into this alignment last year, and our orbit started changing. Now, as you can see, this is the 2024 situation, so our orbit's gradually being dragged out. So what does this mean in terms of figures? Well, let's have a look. Well, as I said, our orbit is nearly circular. It's got a tiny eccentricity, which is the ratio of the long side to the short side of the ellipse. But it's possible for our orbit to have an eccentricity of 0.0679, making one side a fair amount longer than the other. Now this alters the normal distance that we are from the Sun, and it alters it, in this case, in the case of 2024, it alters it in the winter months in the northern hemisphere, and this is important. So normally we're at a distance of 149.6 million kilometers from the Sun, and in the case of 2024, during the winter, the northern hemisphere will see much harsher winters because we're 159.7 million kilometers from the Sun. Now, to give you some idea of what this means, it only sounds like a small increase, but the thing is, you have the inverse square law going on, and the inverse square law basically means that the amount of radiation we receive from the Sun is 1 divided by the distance squared. So normally we'd receive 4.46 times 10 to the minus 17th, that's 0.1700446, of the sun's surface energy, but in 2024 we're only going to receive 3.918 times 10 to the minus 17th. This is a difference of 12.15%, 1/8. So we're only going to be receiving 7/8 of the normal heat that we receive from the sun. And I think you'll agree with me and with the scientists that this is a big difference. The next thing on our shopping list is solar cycles. Now, sunspots are a pretty good indicator of where the sun is at its brightest and its dimmest, because when there's a lot of sunspots there's a lot of activity and churn on the sun, and it tends to be brighter and give us more solar radiation. And what we can see here is that there's both a long-term and a short-term cycle. There's a 400-year long-term cycle, that's the black line, between almost no activity and high activity, and recently it's been high activity and we're now dropping, and by 2020 we'll be well into the drop. In addition, in 2024 we see one of these regular 11-year downswings towards zero activity. And what this means is that, as well as the orbital effect giving us reduced sunlight, we're also going to have reduced sunlight anyway due to the solar cycles. So things are starting to add up, and as if this wasn't enough, there's another factor. That other factor is volcanoes. Now, volcanic ash in the upper atmosphere can stay for a decade and reflects a lot of sun. And there's lots of ash currently in our upper atmosphere. Since 2010 we've had 10 major eruptions, including this one in Iceland at the volcano whose name nobody can pronounce. But the ash is just what's a visible problem. Possibly a bigger problem is sulfur dioxide, which is also produced in tons and tons, which strongly reflects sunlight and persists in its effects in the upper atmosphere for years. And the eruption of Tamboa in 1815 actually produced a year without a summer. So volcanic activity has been on the rise over the last decade, and it seems to be continuing to rise. It seems that almost every month you hear of a new major eruption somewhere, and if this situation continues towards 2020, it will make the Earth even more vulnerable to cooling because of all the dust and all of the sulfur dioxide in our upper atmosphere, reflecting what little sunlight comes from the sun away. So this has been a short summary of the facts that lead scientists to conclude that we could well be in for a mini ice age around about the year 2024, and it's starting now, and you're looking at a 30 to 35 year period is what they think. However, there are a minority number of scientists who think that this period could be even longer, perhaps extending to 400 years. And I'll discuss that one in a future video. Well, I hope you've found this interesting and informative, and you'll go out and buy some nice warm woolly clothing, because one thing's for sure, this year the winter of 2016 is going to be very harsh, and the winters are only going to get worse until 2024. Thanks for watching. Please like, share and subscribe.
Well, you could subscribe to Arduinotronic, or just go jump in a lake.